To prove the following inequality, we can use the induction in reverse order. So this is going to be a different style for induction. For induction, we usually do the following. We try to prove if the statement is true for this one, we try to prove that it's true for n is k plus 1, right? So that's the general usual induction. But we can do different type of induction, and I'm just going to do demonstration of how induction works in numbers. So looking at that demonstration, you can just write out the full proof using induction by yourself. So it's not going to be like formal proof, but I'm going to show how induction works. So let's start by, for example, what if I want to prove this expression for n is equal to 7? So the expression is going to be the following. So we want to prove that this is less than 3. So the process is the following. If I start with the first one, say this number is less than 7. Yeah, so that's because if you just take the squares, you get here you get 49. This is 6 root something. That's obviously true. This is less than 49. Take the squares of both sides, and then this is 6 times a number that's between 2 and 3. So this is approximately 20, and then this is 49. So how about if I say square root of 5, square root of 6, and square root of 7. If I claim that this number is less than 6, can I prove this? It's easy to prove because, so let me erase the 6. That's true because this part of the expression is less than 7 from previous step, right? So this expression is less than 5 times 7, and which is 35, square root of 35, and which is less than 6. So we have the proof of that. So let me erase this. Let's move on. Now think about the next step. How about square root of 4, square root of 5, 6, 7. So this number, so if I look at this part, this is less than 6, right? So I can replace it with 6. So that would be less than 4 times 6, which is 24, and which is less than root of 25, which is 5. And so on. If I continue this, my next step would be square root of 3, square root of 4, and so on up to square root of 7, right? That is less than. So this part, again, is less than 5. I already proved it. So that would be 3 times 5 square root less than, and then that's less than 4. And coming back to the last one, square root of 2, 3, 4, and up to square root of 7. That is less than. So look at this part, that's less than 4, less than, and then this expression whole is 2 times 4, which is less than 3, because this is square root of 8, this is square root of 9, which is 3. So we just started with this expression and then kept adding the next number. So we started with 7 and going down up to 3, right? So this is the how the induction works, because to prove each step we were using the previous one. So how it looks like if I take just like for n in general case. So so for the general case, to start with, we can look at this expression, n minus 1 square root n. It is less than n. You can take the squares of both sides. This one can becomes n squared. This is n minus 1 multiplied by square root of n. So that's obviously correct. So you can verify this easily. So the next one. So if we start going down, the next expression is going to be n minus 2 multiplied by n minus 1 multiplied by square root of n. And this part is less than n. So I'm going to replace it with n minus 2 multiplied by n. That's the expression. So this is less. So the expression becomes larger. And this expression is, if you open the parentheses, you have like n squared minus 2n. So it's definitely less than n squared. So that's less than. So n, that's that would be like. So let me write it like this. As you may have noticed from the previous one, n squared minus 2n. So this number is less than n minus 1 squared, or less than, if I add 1 here, I will get like n squared minus 2n plus 1. So that's larger. And this is equal to n minus 1. So using this chain of inequalities, so let me just remove this. It's less than n minus 1. So if we just keep going like this, yes, let's do the n minus 3 square root n minus 2 and so on up to square root of n. Right? So this part is going to be less than n minus 1, and then I would say that this expression is less than n minus 3 multiplied by n minus 1. And if you open the parentheses and then look at the expression, you can notice that this expression is less than n minus 2. So you just keep going down up to where you get this expression, up to 2, and then this expression is less than 3. So that's how induction works. So when we did it for 7, n is equal to 7, it was more clear. You can write this for general case for n, and write it as a downwards, so it's reverse induction, and prove that this expression true. So there are different ways of using induction. So there is an induction like the usual induction, you do step by step, and there is a reverse induction, or induction where you do like 2 steps at once, or induction, more general induction, you do n steps at once. So there are different ways of using induction. So this one is one of them, the reverse one.